So this guy actually, h of x equals two binomials. These are two binomials being multiplied together, right? This would actually be a good problem for the product rule, because this is what the product rule is for, when you're multiplying multiple things. Problem is we haven't learned the product rule yet. We'll learn it a little bit later, but we haven't learned it yet. So is there a way I can use the power rule for this guy? Because I can't do it the way it is right now. How would I change this around so that I could use the power rule? What would I need to do first? Yeah, so multiply it out, right? Multiply it out. FOIL, multiplication box 2 by 2, however you multiply, right? So that's what I'm going to need to do first. So first, multiply the first two terms. 8x to the third power. Outer, negative 20x squared. Inner, positive 2x. Last, negative 5. Right? Combine like terms if you can, but there's nothing we can combine there. All right, so now that's h of x. Same thing, we just multiplied it out, right? So now you can now we can use the power rule. No more multiplication. It's just the power rule now. So 3 times 3 times 8 is 24. Subtract 1 power. 2 times negative 20 is negative 40. Subtract 1 power. 1 times 2 is just 2. Subtract a power, so it loses an x. Negative 5, the derivative of just negative 5 is 0. Done. Okay? That's one option to do it that way. I'm going to show you right now, I'm going to show you a second option. It's called the product rule. Okay? Product rule. That'll give us the same answer. Okay, so on the next page, I believe, on the next page, we're going to do that problem we just did, we're going to do it again. Except now I'm going to show you using the product rule. So on the next page is the product rule. We use the product rule when we're multiplying two functions together. So u and v are two separate functions, just like 4x squared plus 1 and 2x minus 5 were two separate functions, right? What do we do then? What do we do? Well, this is what we do. We follow this. We take the first, rewrite the first. Whatever the first was, rewrite it. Times the derivative of v, the second. Okay, so the first times the derivative of the second, that's one term, plus the second times the derivative of the first. Okay, so first times the derivative of the second, plus the second times the derivative of the first. Okay, so let's do that same problem we just did using the product rule. Okay, so let's go back. So same problem. H of x equals 4x squared plus 1, 2x minus 5. Find h prime of x. We use this when there's two functions being multiplied together. This on its own is a function. This on its own is a function. Right? On their own, they're each separate functions. They're being multiplied together. So we're going to use, this time, we're going to do the same thing, except we're going to use the power or the product rule. So the product rule says rewrite. The first thing you do is rewrite the first one. So I'm just going to rewrite the yellow. 4x squared plus 1. And then you're going to multiply it times the derivative of the second. What is the derivative of the blue going to be? Just 2. Yeah, just 2. Because the derivative of 2x is 2. And the derivative of negative 5 is 0. So it's just going to be 2. Plus. Now the opposite. Now we're going to rewrite the second one. We're going to rewrite the blue one. So 2x minus 5 times the derivative of the yellow now. What's the derivative of the yellow going to be? 8x. Just 8x. Last thing, do a little bit of distributive property. Because it's 2 times everything. It's negative 8x. It's 8x times everything. So we get 8x squared plus 2 plus 16x squared minus 40x. Combine like terms. You get 24x squared minus 40x plus 2. That's exactly what we got the last time. So it's the same answer, just 2 different ways to do it. Which one do I want you to do? It doesn't matter. That's totally up to you. Totally up to you. Right? Sometimes you look at a problem, like the next one we're going to look at, the product rule might be a little easier to use, but whichever one you want to use, I don't care. You can multiply and then use the power rule, or you can just go straight to the product rule. It's up to you. Okay? It's up to you. All right, so let's look at the next page. Let's look at 8a. Flores. We got 2 functions being multiplied together, just like we did on the last one, right? This is the first guy. This is the second guy. Now, could you use FOIL and do it that way? Yeah, you could. But what's different about this one? What should we do first? Before we make any decisions, what do we need to do first? Square root, yeah. Get rid of the square root. So let's rewrite it. Instead of the square root, what can we write? X to the 1/2 power. Yeah, 1/2 power. 1/2 power means the same thing as square root. Could you do FOIL now? Yeah, absolutely. Go for it. If you want to do FOIL, you can. I'm going to use the product, since we already did that, I'm going to use the product rule since we're just learning the product rule. Okay, so let's do the product rule now. Product rule says rewrite the first one. Times the derivative of the second. What would the derivative of the second be? 15x squared. Good. Mm-hmm. Plus the second one rewritten times the derivative of the first. The derivative of the first is going to be a little more into it because I have a fraction power, right? So I'm going to move the 1/2 to the front times the 2x, and then I'm going to subtract a whole. So when I subtract a whole power from 1/2, what am I left with? Negative 1/2. Good. And then when I multiply here, 1/2 times 2 is just positive 1. Okay, so let me distribute. So 15 times 3 is 45x squared. 15 times 2 is 30. X, what do I do with the powers? I have 2, a power of 2, and a power of 1/2. Do I add them or do I multiply them? I add them, yeah, I add the powers. So 2 plus 1/2 is 2.5, which is the same thing as 5/2. Okay. Over here, I'm going to do the same thing, except I just have a 1 now. So it's just x squared. So all of this just becomes, sorry, x to the negative 1 half, negative 1/2. It's got a coefficient of 1. So it's going to be 5x. If I add 3 plus a negative 1/2, I get 2.5 again. 5/2. And then 1 times 7 is negative 7, x to the negative 1/2. I have some like terms. So I get 45x squared plus 35x to the 5/2 power. This guy over here doesn't have a like term, but I'm going to get rid of the negative. So the negative means move it to the bottom and give it a root. The x gets the negative 1/2 because that's moved to the bottom, and then 1/2 means square root. That answer would be, like I said, more than likely when you see any of these problems we do today, it's going to be on multiple choice. These aren't the ones they put on free response questions. So when you see these, if you see this problem on a multiple choice question, the one I boxed is going to be the one you see. There's nothing wrong with this guy here. There's nothing wrong with this answer here. It's correct. But if you're looking at a multiple choice test, it won't be there. The one I boxed will be. Okay? That'll be the one there. Okay? All right. So now what I want you to do is I want you to do B right under it. I want you to do B on your own, see what you get. Okay, so the first one is 3x minus 2x squared. And then the next one is 4 plus 5x. So I rewrote the first one times the derivative of the second, which is 5, plus the second times the derivative of the difference of this one is that I have 2 binomials over here. It's not just one distributed property, right? So I got to do FOIL over here. First 12, outer negative 16x, inner positive 15x, last negative 20x squared. Combine 15x, negative 16x, and 15x. So I get 14x. And then x squareds. I probably should have done x squareds first. Negative 10 and negative 20 make negative 30. and then plus 12. That's the derivative.
So I kind of forgot, how did you get times 5 and times 3 minus 4x at the end, on the end of each equation?
Right here.
Oh, okay.
So first thing I did was rewrite the first one times the derivative of the second. And then the second one times the derivative of the first. So that's where I got that second part. Okay. That's the product rule. What if I forget? So on the test, you can't use your notes, right? So what if I forget? And I'm like, I accidentally do, and I flip-flop these guys. Is that okay? Yes. Why? Because it's a multiplication and addition, right? And multiplication and addition are commutative, means it doesn't matter which order you do it in, right? As long as you multiply first and then add second, you're fine. The next rule we're going to do, it doesn't follow those, okay? It's called the quotient rule on the next page. The quotient rule. We use this when we divide. That's what quotient is, right? When we're dividing two things. So when we're dividing, this is an option. Okay? So when we're dividing two things, so this is what we're going to do. So let's follow this. When we're dividing two things, first thing we do is we have to draw a fraction. Okay? So we take the one on the bottom, the low, times the derivative of the high, the top one, minus the high times the derivative of the low. So kind of like what we did on the last one. The only difference is there's a subtraction there. And the other difference is it's got a bottom. It's got a denominator now. What is the denominator? Low squared. Bottom squared. So it's low derivative high minus high derivative low over low squared. So how I memorize it is I say low d high, low derivative high, low d high minus high d low over low squared. That's how I memorize it. Because it's low d high, d means derivative, minus high d low over low squared. You're going to use it enough where you won't need to memorize it because you're going to be using it a lot. You only have to memorize things that you don't use often, that you rarely see. Things that you know, like you guys know how to multiply. Like if I gave you two numbers, you don't have to memorize how to multiply, right? You guys know how to multiply because you've done it millions of times. You guys have done it lots. We're going to do this enough where you don't have to memorize it. So I always get the question, do I have to memorize that? Well, I only memorize things that I don't use often. When you do them enough, like do you memorize how to get in a car and drive? Do you memorize like, okay, that's where I push, that's the gas. You only do that when you're in a car that you've never driven before, right? But when you're in your car doing it over and over and over again, you don't need to memorize. Do you need to memorize how to get to school and back? No, because you do it all the time, right? That's kind of like this. We're going to do it enough that you don't have to memorize it. Okay? Okay, so let's look at this one. When do we use this? Well, when we have division. When we have to find the derivative of something with division. Okay? So we got the bottom is a binomial. We got the top is a monomial. Okay, so First thing I do is I always draw the line just to remind myself. So low. Low is x squared and plus 1. So I'm going to rewrite that. Low. D high. Derivative of the high. What is derivative of the top? Just 1, yeah. Minus. I always put brackets with the minus because it's subtracting everything. So low, D high, minus high, x, D low. What's the derivative of the low? Not x, 2x. Yeah, 2x. Low squared. X squared plus 1 squared. Okay, let's clean it up a little bit. So that's the end of the calculus. That is the calculus part. So now we have to do a little bit of algebra, distributive property, combine like terms, that type of thing. Okay? So I'm going to distribute the 1, which is not going to change anything. I'm going to multiply those and then distribute the negative. So I get x squared plus 1 minus 2x squared. Bottom is just x squared plus 1 squared. Combine like terms. Positive 1 x squared, negative 2x squared. I get negative 1x squared plus 1 over x squared plus 1 squared. The top and the bottom look very, very similar. Can I factor them out? No. If this negative wasn't there, you absolutely could. If this negative wasn't there, I could cancel one of these out with one of these and make this a 1. But because that negative is there, it's not the same. They're not the same. I could factor out a negative 1, but then that would make the positive 1 turn to negative, and then they wouldn't be the same. So that's as far as I can go. Done.
Shouldn't that be just 2x or is it 2x squared?
The top, on the top you mean?
Yeah.
Well, I combine these two guys, right? So they're both x squared, so they need to keep their x squared.
Oh.
Okay. That's, like I said, that's the quotient rule. All right. I want you to try B on your own. Try B on your own. See what you get. So low, x cubed plus 1, d high, derivative of the top is 10x, minus high, 5x squared, d low, the derivative of the bottom is just 3x squared, over low squared. Calculus is done. That's the derivative. We just have to do distributive property, combine like terms, those kind of things. Clean it up a little bit. So we're going to distribute here. I'm going to distribute here and multiply at the same time. 10x to the fourth plus 10x minus 15x to the fourth over 3x plus 1 squared. Hold on. Thanks. I can combine some x to the fourths because They both have the same x to the fourth. I get negative 5x to the fourth plus 10x over. You're done. Okay. Those are the two big ones, or the three. There's four big rules that we use, and you know three of the four. Power rule. Did we use the power rule inside of this problem? Yeah, right. We used it. How did we find the derivative of the top? How did we find the derivative of the bottom? We used the power rule, right? So power rule we use all the time. You don't even realize we use it. Power rule is the big one. Product rule is the other one. Quotient rule is the other one. And there's one more that we're going to learn about next week called the chain rule. The chain rule is another biggie. Those are the four ways that we find derivatives. Almost every time we do a problem, you're going to use power rule, product rule, quotient rule, or chain rule. Guaranteed. You might use one or more, but that's essentially what you're going to do. And again, where I see mistakes isn't using the rule, isn't the first step. When I grade papers every year, this is not just this year, it's every year I've done this. This step you guys always do well. You guys can use it well. Where I see mistakes is going from here to here, or going from here to here. That's where I see the mistakes. That's not calculus. That's just combining like terms, distributive property, FOIL, things like that, right? So when people say, "Oh, just the calculus is too much," it's really not. It's the part that I see isn't the calculus. You guys understand the calculus. It's not a lot, right? Product rule, power rule, quotient rule, those aren't a lot of stuff. It's always the other stuff that gets you. Okay? All right, so the last thing we're going to talk about, but I don't think we're going to talk about it today because it's second derivatives. So if I ask you to find the second derivative, what do you think you're going to do? If I ask you to find the second derivative, what do you think you're going to do? Take a wild guess and you'll probably be right. Yeah, you're just finding the derivative of the derivative, right? That's what the second derivative is. So let's go back here. This is the first derivative, right? This is the first derivative, right? How do you think I'd find the second derivative? The same way you do the power rule, right? Move the 2 to the front, negative 60x plus 14. That's the second derivative, right? So that's not that big of a deal. That's what that is. Okay? We'll talk about that tomorrow. What I want you to do is I'm going to give you a couple more problems to do. So find some space. Hopefully you have some space on one of these pages. I'm going to give you two more problems, one product, and one quotient, and we'll be done for today. Okay. So the first one is find the derivative of this guy here. And then the second one is find f prime of x. The derivative of this guy. Okay, do those two. Okay, so I'll go over the first one. Letter C. First thing I had to do was rewrite it. So the bottom is now x to the 1/2. Next step. Low times the derivative of the high minus the high times the derivative of the low. The hardest part about this is that the fraction power, because then you have negative powers, right? That's the power rule. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then the bottom is just squared. Well, 1/2 power times 2, it just makes 1. So the bottom is just going to be x. Okay. Calculus is done, but I got to clean it up. So I distributed the negative to both things. So I distributed here, I distributed there. I distributed on the right and then distributed the negative. Combine like terms. 3 minus 3 halves, which is 1 and 1/2, is just 1 and 1/2. And then the last thing I did was change the negative half. You don't want to leave a negative power. Just change it back to what it was. And I stopped. Mm-hmm.
How'd you get the 1/2 over there?
This guy right here?
Yeah.
This part right here?
Yeah. How'd you get the 1/2?
Because the derivative of the bottom, we use the power rule, right? So the power rule says move 1/2 to the front and subtract a whole power. So if I were to move 1/2 to the front, I get 1/2, and then I got to subtract 1 whole power. That leaves negative 1/2. Okay. All right. And then the second one. The second one was product rule. The second one was product rule. I'm going to post this on Google Classroom. So it's already posted on Google Classroom. So if you didn't get a chance, all of this is posted on Google Classroom. Okay. With the notes. So this guy, again, I had to change the first one to x to the 1/2. So the first rewritten times the derivative of the second plus the second times the derivative of the first. That one you're going to see a lot. The square root of x, you're going to see a lot. It's going to ask you to do that a lot. So it's good to memorize. The derivative of the square root of x is 1/2 x to the negative 1/2. So you don't have to keep doing it every time. Multiply, distributed, combine like terms. And I think that was it. Yeah. Okay. All right. 31, 31, 31. Okay, like I said, all of this is on Google Classroom. So if you didn't get a chance to write it down, it's all on Google Classroom. Okay.